In this lecture, simple we are just discussing two primary concepts that most of the people confused about these two concept in probability theory. Okay, so this concept of simple, what is the independent and what is the mutually exclusive? What is these two things? So first going to the independent. What is mutually independent of the two events? So let's see what is this. So before going to discuss this concept, first see the mathematical definitions of the mutually independent events. So suppose let's take we have two events A and B, and it is said to be the mutually independent if mutually independent or simple independent. If our probability of A by B equals to probability of B, or probability of B by A equals to probability of. This is the simple definitions of the mutually independent, mean or simple A and B are said to independent. This is simple the definitions of the independent event. So suppose now let's take an example. Suppose we have two die. Suppose let's take it is our first die, and let's take it is our second die. So let's take it is our first die, it is our second die, and now we are define the event A in such a way that our first event A will be getting the value of 6 from the first die. Okay, that is it is our die 1 and it is our die 2. So let's define the value first. So first define the event. So our first defined is getting by as defined by okay, getting the value of 6 in die 1. Okay, and let's we are denoted this event d1 is equals to 6. Now our B event will be and simple the mathematical formulations of this event is like that. Okay, so simple here we are considering if we just 6, here we are consider only 3 value. Okay, this is our we are two defined, this is our two defined event. Now we are seeing these two events are mutually independent. Let's see how. So simple, just consider this one first. We are interested to calculate it probability of d1 is equals to 6 with given conditions, probability of d2 is equals to 3. Just see the English definitions. We have just forget the mathematical formulation. Just see the English definitions of this formula. This formula English definitions means what? English definitions mean if we are thrown the two dice, that is d1 and d2, and already we have d2, already we have got the value d2 is equals to 3. Okay, we are just throwing the two dice and already with the value 3 from our die 2, then what will be the probability that our die 1 it is 6? This means that this is the simple language of this formula. So you see the thrown of these two die are totally independent. They are totally not dependent each other. Where if we just throw the two die parallelly, then the A's value will come occur independently. So these things will not depend on this event, that is B event. this thing, this the probability value is totally not dependent on this event, that is what will value occurred in our die 2, that is not matter what will got the value in die 1, totally independent. So what will be the value of this? So simple, this value will be this d1 is equals to 6, because these two events are totally independent. Similarly, if you see this thing, our d2 will be 3. If we have already got our d1 is 6, then it is not dependent on what value we are get from our die 1. It is totally independent on which value we are get from our die 2. So this probability will be simple, this one. Okay, so because of this thing, because of this logic, because of, just say this, just compare these two things, because of these two things, it is the independent event in. So these two events are simply independent events. Okay, these two events are independent. I think now the concept is clear. What is independent events? Now come to the concept of mutually exclusive event. What is it? What is the mutually exclusive event? What is mutually exclusive? So first write down its mathematical formulations, then we are just using this, then we are discussing its concept. Suppose if we have two events A and B, okay, and if our condition probability of A will be given B, if this is similar to probability of B will be given A, if this one equals to 0, then call A and B are said to be mutually exclusive. This is the simple mathematical formula. Suppose let's take now consider two events. Suppose let's take our event A and B. Suppose let's take our event 1. Event A is our die, if we throw the die 1 and if we got 6 value, and event B is if we got the same die, that is d1, and if we got the value 3. Just see these two events. We are throwing the one die, simply one die, and if we got the value 6, then we call this event is A simply, and if we got the value 3, then we call this event is 3 event. Now see if this is mutually exclusive or mutually independent. Let's see. So in previous lecture we have just simple see the definitions of the condition probability. What will be this value? Probability of A with given B means probability of A intersection B divided by probability of B. Oh, sorry, I am just forgetting to mention one thing. If this probability will happen, if probability of B is not is equals to 0, or if our denominator is not is equals to 0, then we can only find this conditional probability value. If we have defined as event such is not totally related to this first event, then how we will find the conditional probability? This is totally meaningless. So first condition will be if our given probability is not is equals to 0, then on this condition only we can find this conditional probability. If we have given a condition such a way that this given condition is not exist, that is its probability is totally 0, then on these conditions how you will find its result, how it's find its probability? It is totally impossible. So just you have to mind this concept first. Our given probability will always be greater than 0. Okay, So similarly, what will be this definitions of this condition probability? Probability of simply B intersections A divided by probability of A. And if you see this simple primary set theory, okay, in 11th standard, in 12th, 11th, I think 9th year, 10th standard, we have already learned probability of A intersection B, probability of B intersection A, B intersection C. We have already this thing in set theory. We have if two these thing are, if this is our A and if this event is our B, then intersections event will be like this one. So these two things are the same thing. So just to see this one, if what when this will be equals to 0, because we have already probability of A and probability of B not is equals to 0, then only it occur if our probability of A intersection B or probability of B intersection both the same thing will be 0. So if it is only occur, then this thing occur. Just now compare this thing, compare this formula with these equations. Okay? Compare this thing. So what will be the event A? Event A, if we rolled a die, that if we got the 0.6, and probably event B is if we rolled a die and if we got the 0.3. Just now see this thing. Just now see this thing. First what this probability means, we have already got this one, probability of B. This probability, I am just writing this thing. Probability of A given B means what? We have already this probability, this event is already happened, and on this event we have to find the probability of A. So this means probability of B is already happened. This means if we throw the die and already we got the 0.3, then after that we expected what will be the value if this value will be 6. This means this already, if we throw this die and we are getting the value 3, in first we have already got it, then we are expecting what will be the value that our 6, the die will come on 6, because in previously got the 3. Then what will be this? This is totally 0, because we have already got the 3 value. Don't expect from this experiment this value come on 6, because totally this value, now this thing will be 0. Okay, understand this geometry? Just read this thing in English language. I think now it is clear. Now let's take this one. Probability of B by A. So this means what? We have already happened our probability of A, means what? We have already, we have already throw the die and we are got the value 6. Now from this one we are expecting what will be the value that this die will given, that is 3. So because we have already got 6, then we cannot expect this thing, this die, the same die will giving the value on the same experiment, that is 3, because we previously got this 6 value from the same experiment. Okay, but in another experiment it can be get this value, but in that experiment we cannot expect this die will give us 3 value, because we already got 6. So this probability will be, this probability will be 0. Okay, now I think this mutually exclusive and mutually independent two concepts are clear. I think many of guys are master of the probability theory, but these two concepts are totally imprecise on them. What is the main difference of mutually independent and mutually exclusive? Mutually independent means totally independent, but the value will happen, but this probability will happen anything. This probability may be anything, but probability mutually exclusive means what we expect it from this probability, that will be totally 0. Okay, because our conditional, that conditions already given on this condition, on these conditions, this our expected probability is totally, and is totally is not defined on the given conditions. So in such situations, our mutually exclusive event occur. Okay, now I think these two concepts are clear from these two different example perspective. Although if you have any problem, please comment below, then I am here. Okay.